Great. Okay. Thanks, everyone. We were absent for a few weeks for travels and holidays, so now we're back. So today's speaker, after I give you the regular updates, is going to be Sir Leonardo Piera from University in Italy on Aldo Moro on Bari. So I met him about a month ago, right, at the Berlin meeting for mitochondria we were looking at, and Sarah had presented a lot of great work looking at therapeutics related to mitochondria. And he's done an extensive amount of work in lots of different fields, COVID being one of them. So when we're talking, he joined our group, and he's going to talk about the work he's been doing here. So I imagine people might be interested. So and I guess you're going to talk about some long COVID things you're dabbling into. So I think a lot of the therapeutics can branch to that. Okay, so let's jump into the COVID news, so I can give him enough time to talk. One of the new papers that came out a few weeks ago, some of you people were involved, is our part 2 review that Sunny had led. They got some nice attention, so it was nice. So if you weren't part of it and you want to take a read, it's the links there. And I mentioned I'm trying to organize a meeting, in-person meeting in Malta, covering RNA, regulatory RNA from tentatively they say it might be the following week, but I'm still looking for sponsors. We have a few sponsors that came through, small amount of money, but there might be more in the horizon coming for bigger stuff. But it's about regulatory RNA covering everything from basic biology to space, but also about infectious diseases, long COVID, and things like that. So if anyone knows about any sponsors that might be interested, University of Malta will host it, my collaborator there. So we got the venue, but we just need a little more sponsorship so we can invite people and then open up the registration. So that way I can invite maybe people here to come to the meeting. But if anyone knows any sponsors, please reach out to me. All right, so let's go into news. I'm going to go through quickly. If you didn't hear, the White House offered more free testing in the U.S. So there was September, there was one, but since the holidays are approaching, November 20th, they said you can actually get 4 more tests. I'm getting mine 4 more today. So if people wanted more tests, here it is. And if you know people in schools, the schools actually also, this came out in the news earlier this week saying, the government's providing free testing for schools. So people in the school world, people have teachers or admins at school, make sure they're aware of this because they can order a free test for schools and give it to students, parents, and so on. We know that this is date from before Thanksgiving in the U.S. holiday, that the hospitalizations are going up, and I'll show you stats to show that it's going up now even more. Unfortunately, it's not, well, I should say we're not surprised because of that, but the wastewater is showing the same thing as we see in the U.S. and Canada and Europe's actually agreeing with us. But one reason that people might be thinking about that is more spikes are happening is this BA2.86 that a few months ago was of concern, but it was some places in Europe like France and other places was starting to pop up, but it's still virtually low. But unfortunately now it's starting to, as we see here, in just the past couple of weeks, it's tripled in cases. And the worrying sum, I think I went over BA2.86 like a month ago, or a month and a half ago now. And due to its enough mutations in this L455S mutation, it's very concerning because of its growth advantage it has, and then what might occur after that. Now that's JN.1 spawned off this. This is the one that people are starting to think might, off the BA2.86, take over and be the one that potentially by Christmas time could be the one that could be dominant. Right now it's HV.1 that's dominant, which is not as transmittable as BA2 or has a growth advantage as BA2.86. But there is some good news. If you had your booster, which hopefully most people have, and encourage people, this preprint came out that said, indeed, since this is from the original XBB variants, since the booster actually does a robust level in this preprint, it's a preprint, take that for a grain of salt, but some data here is showing a robust level for protection against the JN.1, which they think it's going to be dominant. So it's a preprint, again, grain of salt, but at the same time, the data seems pretty compelling here, which is one of the figures from the paper. So that's the good news of it. So the booster can help you with a high level of protection against this nasty BA2.86. That seems to be good.
Can I just quick here?
Yeah, go ahead, Kim.
Yeah, do they discuss co-infections at all, like with RSV or actually even triple infections with just common
Yeah,
flu?
I mean, not in these articles, but yeah, there's been some news articles which I didn't bring up that yeah, that's another concern, right? RSV and the flu, that triple infection that every year they talk about. So that's another big concern too, definitely.
Are there Are you familiar with any incidence rates? I haven't seen any lately.
No, I haven't seen any. I mean, that
Okay.
maybe I just haven't found him.
Hi.
Someone might have looked at him. Yeah, go ahead.
So the internet's not working? Yeah.
Oh, someone's okay. Okay. All right. So yeah, and then some papers I'm going to show. Like this paper came out earlier a couple of weeks ago since we didn't have a meeting at that show. This is an interesting paper where they saw that if for breakthroughs and how the imprinting basically happens, immunity of imprint SARS-CoV-2 happens in your B cells. So this is interesting to see that they talk about. This is the editorial summary of it, where it's a nice summary here. We're talking about related Omicron breakthroughs. That if you had an Omicron breakthrough, and this is after they're looking at the third dose vaccination here, the B cells have this memory imprinted on them that potentially could add a better protection against superimmunity. So that was an interesting paper for you guys to read. And another one, I think I might have presented this a couple of months ago, but a month ago, but I thought I'd show it again just in case. But this is an interesting article talking about how COVID-19 has increased levels of preterm birth. This is one of the figures from the paper. And the vaccinations, as you see this figure, greatly reduces the chance of pregnant women getting the preterm births if they're infected with COVID. So this is, again, I'm whizzing through all this stuff and I'll share all the slides because I think this is just quick snapshots of papers that people might be interested in reading. So I'm putting this as a long COVID news that there's this paper that came out looking at a small cohort, 61 male patients with Omicron infections. But what they saw is that within the 61 male patients, that were, I think they classified as mild symptoms in a sense. They're starting to find this gray matter thickness, as you see here in this one figure from the paper, in one side of the right hippocampus side of the brain. This is a the plot showing like where you might see it more in one region. So potentially they're saying this could be triggering the anxiety and cognitive functions that you see in long COVID patients that are people who are infected with COVID that start getting this increase in this gray matter thickness, which is kind of unsettling. But yeah, read the paper. They don't talk about much of the key biological factors, but this leads to the papers that do. So this is a preprint that came out that actually was interesting. They looked at, it's probably one of the first papers I've seen, it's a preprint again, but one of the first papers that they actually did a nice quantification of looking at symptoms and functional disabilities in severity. So it's like, for example, one of the plots looking how from their paper, 759 patients, 359 patients, with this kind of treatment. But basically, they looked at moderate, severe, and mild conditions of what they had and the symptoms they had, and then correlated it pretty nicely to categorizing it, what kind of severity and symptoms might be associated with each one. So they kind of categorize everything. Now, for potential clinician going here, well, if you had this kind of symptom, potentially you could have this severity. No biology there, but more of the kind of correlation type analysis, which is interesting to read. This is a nice paper here that was looking at related to the brain stuff here, but they basically looked at I highlighted this from the abstract. They basically looked at autopsy from the brains from people who died from COVID or long COVID after the fact. Don't know exactly how long after they had COVID they died, and they were able to get the brains from them. But then they also had a human organoid brain model that they did experiments on, trying to do infecting with SARS-CoV-2 and then doing sort of a long COVID type experiment. But long story short for this is that they basically saw, they identified some key markers related with immune function, but they also and inflammation, but they also identified that potentially this drug, the senolytic, I don't know what it was until I looked it up here. It's basically a small molecule that is involved with senescence. And what they found here is that the virus is inducing this high impact of senescence in the brain area, which I'm not sure if I've ever seen before, but I'm not surprised. But they did a pretty comprehensive panel looking at senescence markers, and then they looked at the 3D organoid models. They gave this treatment to get rid of those senescent cells, and it seemed like to be improving in their organoid model the conditions that be associated with the the senescent cells not coming back after the viral infection. And the main thing is I saw they had RNA-seq data on the autopsy for the brain. So this is another potential resource for us for long COVID to mine the patient samples and the organ. Yeah, Ross, go ahead.
Yeah, sorry. So I have to say I missed this paper. So I mean, this is really interesting because there's a very prominent. I mean, I think I might not have presented this data, but we found that even if we don't see evidence of infection in the brain of patients who died from SARS-CoV-2, we found this just profound upregulation of senescence. And the thing that we could never disentangle or dissociate is obviously, it's possible that maybe patients with enhanced senescence are more likely to die, right? So it's possible that, that's a confounder in our study. But we don't see evidence of other hallmarks of like Parkinson, like other component Alzheimer's or things like this, or these types of issues. So the thing is that the senolytic therapy, that's all in their organoid models. Is that right? Okay.
No human study. Yeah, they did it all organoid.
Yeah, I wasn't sure because there are human studies out there, and I just wasn't sure if maybe they captured some patients who happen to be in clinical trial.
In this case, it was all organoid from my quick skim of the paper this morning. I think that the discussion they were relating it. Yeah, you should try it, clinical trial for long COVID, and see if it'll help them. So, but. Because the therapy is approved by the FDA, right? This is senolytic therapy.
They are, yeah. That's why I wasn't sure if they maybe captured a few patients who happen to be on senolytic therapies. So, it's unlikely, but that would
it was or organoid model thing. But the organoid models, the data, you should read the paper. The data was very promising. So I think it might help your patients that you might see. I don't know. But so this begs the question: is the senescent cells are only in the brain, or is it every organ you see a high amount? Which I haven't seen any. I don't know if you looked at that, Rob, before.
We see senescence in the pancreas, like when we focus in on the islets, in that compartment, and we've also seen it in the kidney, but we haven't looked broadly in every organ.
Yeah, this might be something people should get funding for and try, because if it's in the brain, I don't see why it won't be in any other places too. So.
The question may be also related to what is inducing these senescence in cells. If, for example, you have an accumulation also of, fragments, for example, from the spike protein that are starting to interact with protein targets that are responsible also for senescence. And that is something related maybe also to mitochondrial function, about we spoke in the past. Anyway.
Yeah, they're relating to the inflammatory thing. Actually, I'm sorry, they also did mouse experiments, which I missed when I quickly read the paper. But yeah, they were relating with the inflammation causing the senescence. So that's what they're claiming. But it could be more, right? As you're saying. But yeah, it's an interesting paper. I said I skimmed through it, so I missed a lot of the details that are probably there that Sarah, you bring up, or Rob, you bring up. But I say I got to go back to this paper. And just keep going so I can give Sarah enough time to talk. This is related to this. This is a New York Times article that came out talking about quantifying in the U.S. at least what's happening in adults in 20s and 30s and 40s with long COVID, and what's the cognitive issues I have. Like, for example, you can see the high percentage of people, high, with more high than it should be previously for COVID, but walking down the stairs or remembering things and things like that, which very well could be related to things like we hear and what we see here. And then this interesting paper that came out just this week, looking at cardiac implications of long COVID. They basically looked at different studies, like I said, 150 different studies, and then they basically did some big quantification, ran their algorithms, and they basically saw a lot of these long-term cardiac effects related with, not surprising, but again, no biology here, but I would imagine if they start looking at biology, maybe it's related to the mitochondria thing that we talked about earlier in our papers. Well, that's some interesting papers. I'm going to quickly whiz through this. As I said, the dominant variant right now is HV.1, but I'll show you the CDC tracker in a second. As you can imagine, the wastewater in the U.S., this is mess, or Middlesex County, where I'm at. It was going down, but now the BioBart update, the last one is November 20th, and they sequence it, so it's right around before Thanksgiving, so it's probably a lot higher now. Nationally, it's about the same. CDC actually revamped their site, so they actually have a nice improved wastewater, and I really like how they do it now. Similar to BioBart, but they also have this breakdown between your state and what states are higher level activity overall. Like for example, Minnesota and the Midwest here have a higher level, but you know, and then around like Massachusetts seems like minimal, even though we're having a spike going up. And then also the variant breakdown right now is the EG.5 that was formerly there, but as it said, the CDC tracker for that HV.1 is the dominant one, but you can now see BA2.86, the pink little magenta bar is starting to creep up. And I imagine how quickly it's coming and what's saying the growth advantage, maybe in 2 or 3 weeks, this is going to be where HV.1 is, unfortunately. And this is a breakdown, so you can see the phylogenetic profile of the lineages of the viruses here. And it's not surprising, you know, hospitalizations going up and so on. So I don't know if there's any one quick question or comment. If not, I'll share all the slides.